I could hear somebody asking, is there a subscription for this? There is no subscription. It's an open thing. We will be posting the comments, posting the link in the comments. You can just go through the ticket or whenever you have time. Okay, so we can start the event now. To start the event with a very high note and energy, we have a very special guest with us today. She is very special because she is also an expert worker. I'm sure she doesn't need any introduction, but just for people who are hearing her for the first time, she is none other than Teresa Neat. She is here with us today for delivering the keynote and starting vodQA 2020 with a high note. So Teresa is a QA practice lead and a developer advocate. So she is currently working with the REA group in Australia. As I said, that she's an expert worker, so we are very proud of that. And she has several years of leadership experience. She loves lean and agility and advocates for holistic system quality and system thinking. She also contributes a lot to the community, technology community also. She is the co-founder of DevOps Girls. I think most of you would have heard about DevOps Girls, right? So she is the co-founder and she is a very valuable contributor at DevOps Girls as well. She has written a number of blogs and conducted lots of workshops, and she is very passionate with technology. We will be posting her website also in the comments. You can choose to follow her in LinkedIn and Twitter and get to know more about her. We are very privileged to have Teresa here with us today. It has been possible only because it's a virtual setup, because she is actually in Australia. She's taken the time on a Saturday afternoon, and she is here with us today. Without further ado, let's invite Teresa. Welcome, Teresa, to vodQA 2020. We are all ears to listen to your take on quality. Please take over the stage.
Good morning. Thank you very much for that introduction. I feel very welcome. I feel like friends. I definitely feel like I'm amongst friends today, and I was honored to be invited to speak with you today. For those of you who would like to engage during the talk, we're going to use the chat component of Zoom, so the chat function. I'll be keeping an eye on the chat because I have a few questions during the talk that I would really like to hear or to see your answers to. And then if there are any questions that you'd like me to answer, or if there's something that isn't clear, please use the Q&A component of Zoom. So there's a Q&A button on the bottom of your screen. And then someone will help me collate the questions at the end and act maybe as a facilitator so that I can answer the questions that you pose. So give me a minute or maybe a few seconds while I just share my screen with you. Okay, wonderful. I'm hoping that you can see my PowerPoint first page. If you can't see it, please let me know. Also, just a note that if you want to chat, please use the all panelists and attendees selection on the chat function. Fabulous. So what I am talking about today is testing and quality, and that they're not necessarily correlated. So if you see a correlation, it doesn't mean that there's a causation. And there's unfortunately, a misconception, a tight coupling of testing with quality. And I'd like to slightly separate the two and see if we can have separate conversations about the one and the other and not make them equal to each other. As just mentioned, my introduction is that I'm a QA practice lead at REA Group. It's a digital native company in Australia. And I've been there for 5 years. I was once there as a thought worker. I was once there as a permanent employee, and then I came back 5 years ago, and I've been permanent again since then. REA Group is one of those clients that ThoughtWorks loves engaging with, and that's actually how I discovered REA Group and really wanted to work there when I met them. I'm the DevOps Skills co-organizer, co-founder, and a coach, and I like to run workshops for women who are just starting the conversation on system engineering. And we find that very often in the job market game, men will apply for roles that they're not 100% confident with. They'll have more courage and they'll take a bigger chance. Women don't. Women are, well, if I'm not 100% fit for this role, then I won't apply for the role. So what we try and do is give women more confidence to use the language being used in job advertisements and to have at least a feel that they are equally placed at the table in the conversations. So I say I have IT experience, and I put that in quotes because it means it's a lot of things. So 20 years starting in help desk, and I did a computer science diploma, and then it wasn't a great diploma, so I couldn't start out as a developer like I thought I would. So I went to help desk, and because of the help desk experience, I ended up understanding users and having real empathy for users and bugs and the impact that bugs have on users. And it just is a natural progression. And I didn't see this coming. I found myself looking for a QA job, and that's what happened. I've been a lead QA now for about eight years, probably 15 years as a QA and about 8 years as a lead QA. You can find me on social media at Teresa Neat on Twitter, at DevOps Girls on Twitter, or teresaneat.net. I'm not a massive fan of LinkedIn. You can follow me if you like, but I'm very conservative with connections, purely because I choose the connections with people that I've worked with. And once I get to know you, I'll probably accept a LinkedIn request, which I understand is not how the world sees LinkedIn, but that's how I treat LinkedIn. Now today, we are starting with a conversation on testing. And just for everyone's understanding, I will not denigrate testing, but there's a bigger picture as well. And that's quality. And then how to build in quality. I'm speaking to a ThoughtWorks audience mostly today, and I realize that on the whole, I'm probably preaching to the converted. Like, what I'm telling you is not rocket science, but believe me, other people in the world would treat this as rocket science. So consider yourselves very much privileged that a lot of this will already be known to you. Now, I'd like you to use the chat option and give me the famous last words you've heard as a QA. Just type in the words you hear more often than not as a QA that you know are misconceived or misunderstood, probably from a manager. Let's hear, what are you thinking? What are the famous last words we hear about QA or testing? Zero defects, internal customer test plan. Oh, yes. Just automation, wonderful. I do hear that too. Yeah, regression testing. Oh, 100% automation. Well, I will share with you that I've heard test everything. We're definitely on a roll. I'm going to share with you that there is another famous last words that I've been hearing, and that is, our quality is poor. We need more testers or testing. Now, you'll notice very, very quickly that we can debunk that as a myth, because the causation aspect of testing is misunderstood to quality. There's a term called spurious correlations. Spurious means, big fancy word, it means a falsehood or a lie or a misunderstood concept. And a spurious correlation is when you think one thing is associated with another, but it's not. And in the area of logic or statistics, you'll very often hear people using the terms spurious correlations because people mistakenly associate one cause with another outcome. Now, just to give you a little bit of humorous context, the following is a joke, but it literally is listed on the Spurious Correlations website. So have a look and take in what this image is showing. I'll give you a few seconds to digest that. what we are seeing here is a spurious correlation just because the graphs look similar, where people feel that, and of course this is a joke, but it could be taken seriously, where people feel that the number of people who drowned by falling into a pool correlates with films Nicolas Cage appeared in. Now, hilariously, someone might actually think that there is a correlation that the more Nicolas Cage movies you watch, the more likely you are to drown by falling into a pool. This is a joke, but this is how extreme a spurious correlation can be taken. And there's a spurious correlation between testing and quality. Let me continue. Testing is inspection and feedback. So let's have a look at that image there. That person is inspecting that diamond. The craft of inspection is highly skilled, but it's done after the fact. The quality already exists in that diamond. No amount of inspection is going to improve the quality in that diamond. However, inspection is crucial. You have to inspect it. And at the same time, you have to be able to provide feedback in a way where the person receiving the feedback can respond to it. And this is a subject I'm very passionate about, is using empathy, and the craft of feedback needs to be practiced, and the way we convey that something has gone wrong. And there's more about that later in the talk. We want to be very sensitive and tuned into the person to whom we are giving the feedback. So testing is both inspection and feedback, where we will provide feedback on the quality we have found. Testing is not assurance. You are all quality analysts at ThoughtWorks. Thank goodness you are not called quality assurance, because it occurs after the fact. Your analysis, you apply analysis in your role as analysts. So there's no assurance, and we need to debunk that association as well with quality. However, as I just said, testing is disciplined. And I'll give you one example, something that you might be 100% already familiar with. As a former thought worker, I had the great pleasure of meeting Martin Fowler and being exposed to all of Martin Fowler's work. And it's something you probably would be exposed to every day in your life. But the concept of the testing pyramid is disciplined. And the amount of unit testing you apply to your feature is really important. And you should not overinvest in UI tests if you have UI tests at all. So the fact is that unit tests are much faster, as you can see from the hair on the page, and from the scent symbol, you'll see that it's very, very cheap. But UI tests, on the other hand, are super slow and super costly. They break, they cause false alarms, etc. The middle layer that we see there, we call loosely the service layer. If you read Kent Beck's materials, he's the original creator of the testing pyramid. He will talk about the fact that the service layer is the most neglected of these three layers. In other words, we tend to do some unit testing, a lot of UI testing, and then no integration or service layer. So we want to be doing more service layer. There's any form of integration between the units. We have to minimize our manual testing. And that's actually why I laughed at a comment earlier when you said 100% automation. You'll never hear me say completely kill manual testing, because it can't be done. You have to minimize it, but make it count. And what I mean by making it count is, among others, don't use manual testing where you can use automated testing. Make the manual testing intelligent and exploratory and once off. So manual regression testing is, I'm sure many of you will share, it's a pain and it's an emotional death, manual regression testing. Please don't do that to yourself or to others. We want to automate anything we repeat and make the regression tests, make the manual tests just a once-off. I'm not sure how many of you would have seen this video on YouTube. You see, for instance, a bunch of people with white shirts there and a gorilla in the middle. Now, I will share these slides with you, but when you go to that YouTube video, you are instructed at the beginning of the video to follow the ball. And these people with the white shirts, and I think there's someone with a black shirt there, these people, these humans, are throwing a basketball to each other. And that's lovely. And you're following it like a tennis match, you know, it just goes back and forth, back and forth. And then the video stops and the message is, did you spot the gorilla? And no one spotted the gorilla. So someone in a gorilla suit came in and just moved around with the people, didn't touch the ball, just moved in and out of the crowd. And what we are describing here is called inattentional blindness. It means that you are blind to what you don't pay attention to. So we were looking at the ball, so that's all we saw. We didn't see the gorilla. And that is the problem with manual testing, is you don't know what you can't see. For instance, cross-browser testing. We've created a website and now we have to manually verify that the website renders on every one of our browsers. By the fifth time you are looking at that same page, you are going to start missing things. Fifth time, fourth time, third time. The more you repeat it, the more you have inattentional blindness because you are not looking with fresh eyes. You're not looking with a complete unbiased look. You are looking with a confirmation view. Does this work? Does this work? Does this work? So this is the detriment of manual testing, and it's one of the things we will try and reduce is to automate as much as possible and use your manual testing once off. Testing personnel need to be involved very appropriately. I saw another comment earlier that we can just, you know, reduce testers completely and the developers can do all the testing. That is a utopian nirvana state that only works in a few rare examples where the technical complexity and the business risk is so manageable that you don't need someone else to check what you are doing. So this could be implemented in a number of ways. You can have, for instance, if you don't employ any testers or QAs, you could actually have another developer wear the hat of tester. And it's literally, you are not the developer now, you are the tester. And you have to assume a shift in perspective. And when you are wearing the testing hat, you can't for a minute think that you are being the developer. You have to definitely use the hat of a tester. So when you involve testing personnel, use them appropriately. And this means intelligently, creatively, and not as people who just check and verify that something works at the end. Testing has to be continuous, just like feedback. Just like inspection and feedback, testing should be continuous. And the following image is borrowed from a friend in the UK. It's probably a name you know, called Dan Ashby. And he talks about the various points in the life cycle where you could do testing. And in fact, you should do testing. I'm going to give you a little bit of an opportunity to put in the chat, if you could include some thoughts around a phase or activity such as build, monitor, release, deploy. What could you be doing there for testing? So just, if you wouldn't mind, just putting some thoughts on what type of testing we could do at various stages in this life cycle. I'd be watching for your comments now. Sanity checks, functional testing. Yeah, requirement analysis is super important. Yes, requirement review. Typically, we think we might be doing that at planning. Very valid. So if you give me these types of testing, can you associate them with a particular point in the life cycle? So what about release? What about deploy? What about monitor? What about operate? Could you link a type of testing to a particular stage on the life cycle? Yeah, definitely sanity when operating or deploying. I'll tell you my thoughts. I've had a few conversations with people already, and there's no perfect answer here. It's based on the context, of course, of your scenario. And some people disagree with the naming of these particular life cycle points, but I'm not going to pick that fight. For me, this is just sort of a loose conversation. So on plan, we will definitely be doing some requirements review. On branching, when we are branching from the master branch or the trunk, we definitely want to run the existing tests, the existing automated tests, and check that they still work. In code, let's hope that you are doing unit tests. You're doing some form of TDD. By the way, I'm a huge fan of BDD and TDD, and you'll hear more about my talk, my thoughts on that later in the talk. When you're merging, I'm really hoping that you have now written integration tests or service tests and everything is working there. When we are building the artifact, definitely want to run the entire suite of automated tests at this stage. By the way, at any point in this diagram that we see here, you could apply manual testing, but you do it intelligently and in an exploratory fashion. With releasing, now releasing is a term that is sometimes associated with deploy. Releasing means that we have just placed it in the environment. It's not necessarily visible to our clients or customers yet. So with releases, you could, for instance, do performance testing. You can do anything. You may want to do sanity testing. Any form of feedback that you haven't required up to now, you'd be doing that. Deploying, definitely do some smoke tests. Definitely turn on the application and see whether the smoke comes out of the application. That's called a smoke test. Operate. It's in the environment. It's already running. How do you keep an eye on it? Well, you're not going to run a whole test suite against it, but you will be applying some form of feedback. So that could be with analytics, that could be with logging and other forms of feedback that you want to be applying here. You could even, if you want to do some A/B testing, I saw mention of A/B testing earlier, so I really like that. A/B testing is a fantastic way of getting feedback on whether, which experience is most preferred. And of course, if you apply your own subjective thinking to it, you'll apply a bias to it, which is why we do it in production against real people. Monitoring, which you probably will guess is my personal favorite because I'm a bit of a DevOps girl and I want to see how this thing behaves after some time. And I want to build in, by the way, and as many of you will know, that we build in quality from the start. And as, for instance, you build in some monitoring as well. So you start speccing out your monitoring tools at the beginning. And now is the point where we can see how you can use various tools, New Relic, etc. How is this application behaving? So this is testing being continuous, it's disciplined. We have to move on to quality because that's the next logical step. And quality is value to some person. This is a quote from Jerry Weinberg. Has anyone heard any other definitions of quality? If you wouldn't mind putting that in the chat. There's some famous ones that I like to debunk, but let's hear if you've heard. What is quality in your assessment? Responsibility of the entire team. Yes, it should be. You're right. Zero error. That's a famous one. Yeah. Value and customer satisfaction. Now we're getting warm. So, meeting customer needs, prod ready, unbreakable product. Okay. Quality is contextual. Quality is based on your context. So it is literally the value that you're delivering to somebody. And therefore you need to understand who your customer is and what value looks like to them. It is not, one of the ones I've heard in the past is it's not 100% meeting of requirements, because the requirements could be wrong or outdated. So we can't say it's 100% meeting requirements. We can't say it's 0 defects, because that is truly unrealistic. You can always find defects. We can't say it's unbreakable, because anyone can break it, or any really good QA or penetration tester can definitely break it or hack it. So it's value. And so value needs to be measured continuously. So let's talk about quality, sort of the big picture conversation from here. To get a grip on whether we are actually achieving quality, we have to measure quality. And no surprise, testing is included in measuring quality. So testing is not assurance. It doesn't improve quality, but it definitely gives you a measure on quality. Static analysis, whether that is code or whether that's a requirements review, that really does help you measure quality from the very outset, and you can therefore act on it and improve quality later on. Linting is a form of feedback for anyone who's a developer or automation engineer. You'll know that you apply linting to see whether your code is conforming with the requirements of that particular language. And you can plug in a linting tool into your integrated development environment and get feedback as you type. So very, very good to get that early feedback. Testability analysis is something I'm a huge fan of, because what we can do is we can have a look at what is the definition of done and how do we verify that. This is not necessarily just code. This is not necessarily just adding titles to elements in HTML or in your DOM. This is about the whole conversation of how do we see whether this is complete? How do we measure that? I have mentioned BDD or TDD. It's an excellent form of having a quick and a continuous and an early measure of quality. With behavior-driven development or test-driven development, we are literally writing the tests before we write the code, which means that the code is just enough. We're not writing excessive code, and we're writing the right code because the test then passes. Continuous integration, I understand, is a hot topic, and everyone wants to do continuous integration because it's a cool tool, but this is not about the tool. This is about the feedback as we are integrating every piece of functionality, which, by the way, continuous, a famous quote I like to use is, continuous is more often than you think. Some people think continuous integration is once a week. Some people think it's maybe once a day. I think continuous integration is frequently during the day. So as you integrate, you immediately measure quality because you'll have some tests that run, and you'll be able to see whether the code you wrote or the tests that you wrote now actually work in that context. I'm a huge fan of UX research because what we do is we interview the customer and we get their perspective. And you can do that before, during, and after you create a feature, and always get that feedback. Again, feedback is measurement and getting that understanding of whether something is right or wrong. And if it's wrong, then you can respond to it. And again, monitoring and alerting, something that you'll probably know by now, I really, really like. Okay, we've measured quality. We have some understanding. We have, for instance, had a post-mortem, a bug's been raised, we're having a bug triage. Now we respond to the feedback. So one example is I'm not sure if many of you go to postmortems. We call them post-incident reviews. This is when we have incidents in production. And a bug triage could be something where you found a bug earlier before production. Could I see just by a show of yes, maybe in the chat, can you tell me if any of you attend postmortems or bug triages? I'm really pleased to see that. Does anyone not go to a postmortem or bug triage, and do you feel excluded from them? Yeah. Okay. That's great. I'm glad to hear you participate, because in some really old enterprise silo environments, we have the exclusion of QAs in especially production conversations. And this is something that really concerns me. And it's something that if I'm your leader, I will bring you into the conversation, because your perspective is so important. So when we have this reaction to feedback, either in a post-mortem or a bug triage, the following is important to understand. I'm going to read to you this quote. It's from the SRE handbook. It says, you can't fix people, but you can fix systems and processes to better support people making the right choices when designing and maintaining complex systems. So I'm going to linger on this for a second and just share with you my thought on that. Is when we are having postmortems or bug triages or any form of response to a reduction in quality, the wrong focus is, and the wrong conclusion to reach at the end of it is that someone made a mistake. Yeah, of course people make mistakes, but people are trying their best, always, 100%. So we have to understand, why did they make the mistake? And we should not focus on trying to fix people, but we want to focus on improving the system that failed that person. Example, we had a recent issue in production where we had a GraphQL API, and there was a misunderstanding of how GraphQL works. It's our first GraphQL API. Made a mistake, went to production, caused an issue, and we had a post-mortem. And at the conclusion of the post-mortem, someone said, oh, we had a junior developer and we just needed to train her better. And I was, no, we don't fix the person. It's not that we should have trained her better. We should now ask, why didn't we train her? And we should fix that. So I really want for you to think about the fact that the system will fail someone, and their response would be, as a result of the system, please don't target people because they will feel unsafe. And there's a whole topic on this called just culture. So yes, you have to fix the process. It's always the process. People respond to processes. If I'm going to talk about it later, actually, Just Culture by Dr. Sydney Decker. And I should probably do a talk on that alone, because if you get me started, I might not stop. But let's move on. So, okay, we're going to build in quality. We have some form of feedback. We've come in, we've responded to it. But what now if you take a proactive approach and we build in quality? This is before we have feedback. This is before we think something is wrong. So what we're going to do is take a proactive look. And here are some ideas. Work slicing, and please bear with me. I'm not putting anything in any sort of priority order here. I'm just telling you some ideas that you could use. Work slicing is the following. We want to vertically slice. We want to be able to look after the work in a way that we are integrating the work continuously. All of these links will be available to you. But I'm guessing that for this particular audience, vertically slicing is not unfamiliar territory. That is how you build in quality. That's how you begin with building in quality. Another one, reducing waste. Waste is, and you can look at that link, waste is any form of added friction and unnecessary process, unnecessary conversations, handovers, etc. All of that is waste. If you reduce that, you'll be surprised to know that your quality improves, and you can actually measure it if you have two systems working parallel. Flow. DORA metrics, thankfully something that the ThoughtWorks audience would be very familiar with. It's something that the Tech Radar adopts. Just culture. I mentioned it earlier. This is Dr. Sidney Dekker. He is a PhD, and he talked about the just culture, and just meaning fair. So a fair culture and how we respond to issues. And his YouTube video talks about being fair in the culture of a hospital, and literally where lives are on the line. So just culture. How do you respond in a way that is safe and secure, and people can make mistakes and it's okay, and you're not going to get fired? Someone's going to help improve the process. And then a whole bunch of collaboration and visibility ideas. I would probably not need to try and convert you on any of these. You would be very familiar with them. Pair programming. I'm a massive fan of both pair programming and pair testing. Pull requests, something that you would know if you're writing code. You submit a request to the master branch or the trunk, and someone would need to review it. And again, feedback needs to be applied in the pull requests. People can be far too brutal during pull requests, and how you respond to this really, really matters. TDD or BDD or any driven development, ATDD, there's a list of them. I advise you apply it based on your context. Test coverage is a conversation that can get you in a little bit of strife, because people will say to you, we need 100% test coverage. 100% is not achievable. So please, I actually had a manager who gave me 100% test coverage as a KPI, as a performance metric. And it's really, really sad, because then you can just fake it. You can just say assert true for everything, and I have 100% test coverage. So it's very naughty. Don't do that. We want to talk about test coverage when we know, for instance, something is wrong. Issue in production, does it have a test? That's when you have the test coverage conversation. Kickoffs. I'm a massive fan of kickoffs. I love a kickoff more than I love just about anything in Agile. The thing with a kickoff is we catch so many bugs early on. We're actually building quality so well with a kickoff. And you'll find very often that without a thorough and a meaningful kickoff, many issues will occur later on with a particular feature. I would imagine many of you are familiar with the term systems thinking. So systems thinking is about thinking about the big picture, not just the component you're working on. You're considering the whole system. You're just not thinking about the component only. It's something that a QA does extremely well. We can all probably cite many arguments we had with developers who feel that their particular item is perfectly tested, and why are you thinking about the integration components? We have to think about systems thinking. And this is one of the things that I train QAs in when they start their journey as a QA, is systems thinking. So there's a moral to this story, and I'm not going to ask you for your thoughts, but I'm going to tell you what it is. Quality has both a proactive and a reactive approach. So we have to apply both. I'm not saying testing should not be applied. I'm saying it's 50% of the conversation. There's a proactive value that you can add as a QA as well. As I said, good testing is essential for valuable feedback. So see testing as feedback, not assurance. And then when you apply testing, think quality of testing, not quantity of testing, as opposed to have a metric of, I need 100 tests, which is a silly metric. Think about, I want the best coverage of tests. I want quality tests. And you want to be reviewing these tests, by the way. Don't write tests and then park them. Write tests and continue to review them very frequently for relevance. And if it's not already clear to you, you can't test in quality. Okay, let's close this. Here's a quote from Dr. Deming. He was the founder of the lean manufacturing system. He had traveled to Toyota in Japan, where the Toyota production system came up. It's the whole beginning of the lean conversation. And by the way, flow and all these other things I referenced earlier. Dr. Deming says, inspection is too late. The quality, good or bad, is already in the product. And I think with that thought, I'm going to leave you with that and not say anything more. Tell you where you can find more information and my contact info. Just again, it's at Teresa Neat at DevOps Girls or teresaneat.net. And if you're in any of the Slack channels, public Slack channels like Ministry of Testing or Test Automation University or Rapid Software Testing, you can reach me there as well. I understand that you may have questions that we can't answer today, so that's where you can find me. And follow me on LinkedIn if you like, and then hopefully we get to work together one day and we can become LinkedIn connections. And with that last thought, I'm going to thank you all for your time today, and let's see whether we can actually answer questions at this time.
Thank you so much, Sarah. Everyone of us has got a new perspective on quality and testing now. As you said, it helps us. Yeah, do you?
I seem to be having a connection issue here, so give me a second while I close 100 apps and see if I can hear you again.
Yeah, no problem.
Okay, now I can hear you. Could you please repeat that?
Yeah, shall we start with the questions now? I see there are like
let's go for it.
More than 10 questions. Let's see if we can just pick a couple of them and see if we can answer them. Let's see this one. How do we handle questions on test coverage?
It's a great question. So this is something that might surprise you, is that I repeat myself about 100 times a year on the same questions. People ask me questions that I'm sure I've already answered. And this is one of the questions that I get asked, is I engage with people empathetically, and I understand that people have their own journeys and they may not be on the same path as I am. And to them, it might be a new question, and to them, it might be, well, obviously you talk about test coverage. So the first thing you want to do when people ask you about test coverage is understand the problem they're trying to solve. There's usually a problem they are trying to solve, and we want to be able to solve that. Test coverage is an implementation detail. So what we want to do is see whether we can rather solve the problem. It may involve some test coverage, but someone who tells you that test coverage is the answer has not told you the problem. So I'd rather ask them about the problem.
Okay. Thanks, Teresa. I think we have 2 more minutes. Maybe we can try and quickly fit in one more question. In terms of improving quality, lots of terms to assess quality and work on improvement like TMMI, CTP, etc. So the question is, are they really useful? If yes, how can we start on it?
Oh, what a great question. So I don't think they're really useful. I'm terribly sorry. I'm not a fan of certifications and branding and anyone who pushes an agenda, and I will probably be that critical thinker who goes, no, I will be the one asking why and asking you about your problem, but not necessarily going with that particular solution. I don't feel frameworks, unless you understand the problem really, really deeply, I don't think a framework is the answer, because everyone's situation is unique and needs to be applied differently.
Thank you so much, Teresa. I think it's been wonderful having you here. There are more questions, for you. Maybe during the talk you can keep answering them in the Q&A section, and people can get the answers from you. Thanks so much again. It was wonderful having you. Yeah.
Thank you for having me.
Yeah. Okay, people. Let's move on now. So we have a polling option just to collect your feedback on every talk that we are presenting today. So you will see a polling options on your screen right now. We'll just take a couple of moments so that you can answer them, and then we'll move on with the next talk. Yeah, I see almost 50% of people have already, voted on the polls. A few more people, and we'll just get started on the next one. Just 2 questions, so. Okay, I think we have gathered almost, most of them have given the feedback now. We will now end the poll, and then let's move on to the next talk of this webinar. Okay, so the next talk is from our very own thought worker, Kumar Saurabh. Saurabh has over 10 years of experience in the field of quality, and he has worked extensively on testing various mobile and web applications across different platforms. Today, he's going to talk about event-driven architecture for QA. So as we had with Teresa, we'll also have a small Q&A session at the end. So please keep your questions coming in the Q&A section. Welcome to vodQA, Saurabh.
Thank you, Akshita. Hello, everyone. Today, I'm going to talk about event-driven architecture. Let me take a few seconds to share my screen. Hope everyone can see my screen. So this is a lightning talk for approximately 20 minutes. So you can post your questions in Q&A window. If time permits, then I will take the questions at the end of the session, or will try to answer after the session. The link for my LinkedIn profile is also present. You can post your questions there as well. We can connect later on for the same. Starting with the talk, event-driven architecture for QAs. Agenda for my talk is, what is event-driven architecture? Event-driven architecture models, challenges with respect to testing, ways of testing event-driven architecture. What is an event? An event is not same as event notification. Then what is an event? An event is significant occurrence or change in state. It is a condition that triggers a notification. It is agnostic of underlying technology, always public in nature, immutable in nature. It is locally consumed but distributed. The consumer address has changed. This is one of the example of an event. The inventory has been relocated. This is another example of event. Now, what is an event-driven architecture? On the left-hand side, you can see we have event producer, and right-hand side, we have event consumer. And in the center, you can see there is the messaging queue where the events are getting pushed. Producer generates the event and pushes the events to the queue. These events are asynchronous in nature, which means the order of the event reaching the customer is not controlled, and the consumer who have subscribed to the respective topic can only consume these events. Who are the participants in an event-driven architecture? The first one is the producer who has emitted the event, then the consumer, listener or sinks who is waiting for the event to happen, the processor who will consume the event, reaction, what happens when the event has been triggered. Then at the bottom, we can see the messaging infrastructure, which is responsible for transmitting the events. This is a real-time example of like how a retail website works with event-driven architecture. On the left-hand side, you can see the event producer like retail web app, mobile app, point of sale. These are event producer and emit events. Like you can see that in the diagram that placing a new order, question about stock, return request, these are the events which are pushed to the routers. Event router pushes these events to appropriate consumers or subscribers like warehouse management. These are the consumers on the right hand side, finance system or the consumer relationship system who have subscribed for this event. So this is how event driven architecture works in real time. Now coming to event driven architecture models. The first one is publisher subscription model. This is a messaging infrastructure which keeps tracks of subscription. When an event is pushed, it sends the events to each subscriber. After the event is received, it cannot be replayed and a new subscription do not see the event. Example of this type of model is Google pops up. Second is event streaming model. In event streaming model, events are written to logs. Events are strictly ordered and durable. Clients do not subscribe to stream. Instead, a client can read from any part of the stream. The client is responsible for advancing its position in the stream. This means client can join at any time and can replay events. Example of this type of event is Kafka or RabbitMQ. When to use event-driven architecture? When you have multiple systems to process the same event, there are multiple systems like inventory is there. Once you have placed order, the inventory should get updated. Suppose shipping information should get updated. So same event is flowing to two different subsystems. So this is a good example when we can use EDA. Then next is real-time processing with minimum time lag. For example, in e-commerce website, complex event processing such as pattern matching or aggregation over time window. And next is high volume, high velocity of data such as IoT system. All these are good use cases where we can use EDA. What are the challenges in testing EDA? The first one is integration testing and debugging. To write an effective integration test case, a quality assurance engineer should have thorough knowledge regarding each of the various services that a software is delivering. Analyzing logs across multiple services could be very tricky. So that's why this is one of the challenges. The next is struggling coordination between the teams. When there are multiple teams working independently and everyone is developing a software, to get an idle time window to test the overall software, it is a real challenge. So proper coordination is needed in this type of systems. Decoupling of database. When we are developing multiple microservices, single business capability is, each of this business capability is responsible for one functionality and has its own database. So testing these systems becomes more complex. Next, complexity. The complexity is directly proportional to the number of microservices which we are delivering. So this is also one of the challenge. Then performance testing. Performance testing, if you're transitioning from a monolithic EDA architecture to EDA architecture, then large number of tiny components are bound to be generated. These components should be communicate consistently. Performance testing for business transaction is very challenging in such case. So again, testing becomes tough. Now coming to functional testing, testing EDAs. So there are two things. First is functional testing and second is non-functional testing. Coming to the functional testing, the first one is unit testing. Unit testing is more or less same as how we do in any other system. We can use mocks or interceptor in initial phase of development for writing the unit test cases. Now coming to the integration testing. This is a bit complex as we don't know when the event is triggered and when it will reach the consumer. So we have to solve this problem. How we are going to solve this problem? Producer can create event and push it to the queue. Testing team can create separate topic and consumers can subscribe to this topic to listen. In this case, testing can be done in real time without much delay. So, and we can do integration testing. Again, contract testing, is more or less same how we do in any other system. We can use tools like packed and we get response in JSON or XML format. Next is non-functional testing. As part of non-functional testing, the first one is performance testing, the second one is resilience testing, and the third one is security testing. These things I will be covering in a bit more detail. Coming to the first one, performance testing. Performance testing of event-driven architecture is important as well as complex. Since there are a lot of moving parts in this system, this architecture, so we need to do a performance testing of each of the component and as well as the subsystem. We have to also test the end-to-end system as a whole. Then only we can identify and benchmark the performance of overall system. So what are we testing in performance testing? First one is to find all the bottlenecks causing the performance issue. Then identify the capacity of the application to handle the load. Third is identifying the optimal infrastructure required for the peak load. Why this is an important thing? Since most of the microservices are hosted on separate node or instance in cloud, so identifying the optimal infrastructure for each component is important for the capacity planning and estimating. The approximate cost which can be incurred can be calculated once we get the proper performance, proper infrastructure on the system. Next is benchmark the endpoint for existing performance. This is also one of the thing what we need to test in performance as part of performance testing. What are the metrics for the performance testing? The first one is data rate. What is data rate? It is a number of input processed per second, which is composed of three things. The first one is number of messages sent or added in the queue, number of messages deleted from the queue, approximate number of messages which is visible in the queue, or we can say unacted messages. The second one is latency. Latency is the time taken for the output event to emerge from the system after the input event has happened. In this case, what happens, since we are working in asynchronous system, so when we are receiving the output at the other end, the timestamp for all these events are not in the proper order. So initial latency, what we measure is not the actual latency, and it is called the information latency. Once all these event gets processed with the proper timestamp, then we get the proper system latency. Other metrics which we measure as part of this performance are throughput, response time, and infrastructure which will be used. All these factors are also important, but these are the most important factor when we are working EDA. Now coming to the next thing, that is prerequisite before starting the performance testing. The first one is the get the expected load. So what do we mean by the get the expected load or SLA? It means like since we have a lot of components in a system, so for each of this component, we need to identify that what will be the SLA. For each of this component, the SLA may vary. So if we are working in a, suppose we are like moving to a cloud platform from a monolithic architecture or a SO architecture, and we have certain tools which are already configured in the system, like Grafana, Instana, or any of the monitoring tool. So it is easy to get this SLA from those monitoring tools. But suppose we are building from the scratch, then we have to depend on the business to get the actual numbers. And these are really important to get in the initial phase of development so that we can develop our system properly. Now, next is enabling distributed tracing throughout the enterprise, which means like, since we are working event, we don't know when the event will get triggered. So, and when that event will reach to the other system. So logging is one of the most important thing which help us to trace where that event has gone. So this is also important when we are we have upstream system or downstream system which are not in the cloud. They are maybe on-premise system, but to test the overall performance of the system, we need to log everything properly. Then only we will be able to identify the bottlenecks. Next is setting up the performance environment. It should be generally like a production-like environment, and so that we can get the actual results. Then setting up the test data, and it definitely should not be mocked. Coming to the factors which can impact the performance. The first factor is network input, output to and from the queue, messaging queue. So when that packet is entering to the message queue and when it is coming out of the queue, and how that queue has been implemented, if it is a parallel stream or a sequential stream, all these factors adds a lot of value to how the performance of the system will be. Now, next is efficiency of the message queue. Then efficiency of the algorithm, which is processing the event. It is also one of the important factor for event-driven architecture. Next is the structure of the message, event message can affect the system performance. So how the structure of the message is there, what should be added in the message, what should be the part of the header, what should be the response, how much, what should be the length of optimal length of the message. All these factors are the part of the message. Then next is performance test visualization. Here on the left-hand side, you can see that number of messages which are published with respect to the time, and the number of messages which are processed with respect to the time. This information helps us to calculate the data rate, which we discussed earlier. On the right-hand side, we can see the throughput, which denoted by the elements or the packets of the data, which are processed per second. With the help of these graphs, we can analyze the performance of the system under test and identify the bottlenecks if there are any. So these graphs are really important, and it should be monitored properly once we are doing the performance testing, and after that we can analyze these graphs to identify all the bottlenecks. Now coming to the tools which needs to be used, there are a number of tools which are available. Some of them are open source, others are licensed. Depending on the need and the business requirement, proper tools should be chosen. Here are a few examples. The first one is a Locust, second is Gatling, Apache, JMeter, BlazeMeter. So depending on the requirement and the business need, one can choose a tool, as well as it also depends on you want to go for open source or licensed and the need of the project. Now coming to the next non-functional part, that is resilience testing. Resilience testing is also one part of non-functional testing. It is a method of software testing that focuses on ensuring the application will perform well in real life or chaotic conditions. In other words, it is the ability of an application to withstand the stressful or challenging factors like time to recover from a sort of failure condition. So what could be the failure conditions? Like one of the node is not responding, the load on the system is huge, it is much beyond what you had expected. So the time to recover from such scenario is covered as part of resilience testing. How resilience testing works? Set up a system to test. We need to set up select a system which we want to test. Suppose we want to test the payment system or inventory or the overall system. We need to select the system. Set up an isolated test environment. So in this case, if we are running in a Docker container or a local system or a cloud instance, we need to select an isolated environment where we want to do a resilience testing. The next is apply the principle of chaos engineering. What is chaos engineering? Chaos engineering is the principle of experimenting or distributed system in order to build confidence in the system capability to withstand a turbulence condition in production. And this was started by Netflix in 2010, and Chaos Monkey was one of the tools. Now, as part of the relevant chaos engineering, what are the things we do? First is identify the relevant metrics which should be measured as part of chaos engineering. The metrics could be the input-output rates, throughput, time to recovery, latency, relationship between metrics. These are some of the things which should be covered as part of collecting the relevant metrics. Now establish a performance baseline, which means the maximum load which a software can handle without experiencing the performance issue. So this is again very important in EDA. So we need to identify that what is the maximum load our system can bear. Otherwise, we can set up a disaster recovery cluster for the production, suppose, and we can point out, like if in case of any failure or something is not working, we can point out our application to a disaster recovery cluster. Introduction to introduce disruptions and measure impacts. As part of this, I'll give one example in the next slide, how to introduce a disruption. I'll be covering the traffic disruption. So as part of this one, what are things are there? Disrupting the communication with external dependency, injecting malicious input, manipulating traffic control, constraining bandwidth, and shutting down interfaces system, deleting data source and consuming the system resources. These are some of the examples where you can introduce a disruption in the system. Now, once you have done all this, you can plot a graph and collect all the metrics, discuss with the team, and sometimes this really helps us to identify some of the test cases which we have not covered as part of functional testing or performance testing. So some of the things which remain untested, those can be covered, as well as it helps us to identify what are the issues could occur in the production. Now, coming to the example of network disturbance, the Linux tool TC, and there is a tool called Pumbaa. Linux tool TC allows the manipulation of traffic control setting for a specific network devices on AWS systems. Pumbaa is a wraparound TC that makes it easier to selectively apply simulated network issue in Docker container. Now, TC Netim is a functionality of Linux TC tool, which allows to manipulate several aspects pertaining to delivery of packets, like adding packet delay, simulating packet loss, constraining the bandwidth, duplicating and reordering the packets. These are some of the things which could happen in an EDA architecture. Next is, for instance, suppose you want to induce a packet delay of 200 millisecond or a packet loss of 10%, then you can use these commands. TC specifies for the traffic control, qdis is a modify the scheduler, add is adding a new rule, dev eth0, you are applying a rule on a specific device on Ethernet 0, root is modify the output traffic scheduler, netim is using the network emulator to emulate a WAN property, loss or delay is the network disturbance which we want to apply. Now coming to the next slide, issues identified in resilience testing. Some of the issues identified are like you can get aware of the logging improvements which needs to be done, improvements in the broken connection in the messaging queue, malformed messages, or a node which is not responding, events are not flowing due to memory leaks. These are some of the things which gets identified. Now, tools for resilience testing. These are some of the tools. First one is like Netflix Siemens Army is developed by Netflix in 2011 after the Chaos Monkey, which became very much popular in 2010. And Fit failure injection tool is again one of the tools from Netflix only. Pumbaa, which we already discussed, it is a chaos testing for Docker container. Now moving to the next one, security testing. Security testing is again a non-functional testing, and it is really important how we handle our event-driven architecture, how the events are handled, and it is very much prone to a lot of vulnerabilities, even though it is hosted on a cloud system. So to do a proper security testing, it is really important. The first one I want to cover is handling of events. Since everything is a events in event-driven architecture, producers are emitting the events, and it is going into the message queue. There are consumers who are consuming the events, but we should be very much careful, like who are the consumers who have subscribed to those events to listen, subscribe to those messages to listen, and they should only consume those events, not the one who have not subscribed for it. Next is logging should be taken care. What should be logged in the event-driven architecture is really important. What everything should be hashed or everything should be not hashed. What should be masked, like payment-related information, this should be masked, and what should not be logged. In case of any security vulnerabilities, these logs help us really well to identify where the security vulnerability has happened and to fix that thing in a proper time. Multi-layer authentication is really important in such case, and it is important because since not all the consumers or producers are part of the same system. They could be on-premise system or in the cloud. So a multi-layer authentication is really needed to implement and should be taken care of properly. Next is security of endpoint via PubSub. Suppose they're on-premise system who are consuming your events and they are not in the cloud, but you should put proper security features when they are going outside the cloud. You are taking care of the system under test, but those should be also be taken care of properly. Next is security threat modeling. This is again very important. As part of this one, we take the proper architectural diagram of the application and then identify the most of the issues which can happen. We apply the STRIDE model, which is spoofed identity, tampering with the inputs, repudiation of action, information disclosure, denial of service, elevation of privilege. And this helps us to identify a lot of issue in case of ADA. Now coming to the references, I think I have covered everything. Thank you, everyone. I hope it is a good talk for you. Thanks.
Hey, Amit. Hey, Kumar. It was a very good presentation. You have a couple of minutes to take Q&A. If you would like to take it from the Q&A session, you can choose 1 or 2 questions that you want to answer live, and the rest you can take it offline.
Okay, sure. The first one, is it necessary to be a deep thinker to become a good tester?
Saurav, you can go to the ADA section.
Yeah. Does this EA relates to Kafka? I see this concept is more or less same as the Apache uses. Yes, event-driven architecture relates to Kafka, and it is, I told you, it is one of the streaming model. We can either apply a publisher subscription model, or we can use Kafka. How we want to implement our architecture depends on. In event-driven architecture, there could be some part which are asynchronous in nature, and there could be some part which are synchronous in nature. And depending on our need, we can implement that. Now, next question is, testing ADA just like notification are pushed to various systems from one publisher. How can we get so many systems for testing? Yes, for testing such systems, as I told, it is a sort of a bit tricky. For since events are pushed to the messaging queue, then for the testing team, they have to create their own topics, and the consumer will listen to only those topics, a topic which is specific to our testing team. How we create testing data in any other system, here also we create testing topics, like and then we can get our message instantaneously. So we don't have to wait for all other messages, and this can help us in testing quickly and fast. Are there expected to do such type of testing? Yeah, there are like multiple tools you can use. For, as I mentioned, like if you want to go for the testing the performance or security, I have already mentioned some of the tools. And if you want to automate such scenarios, you can automate using the existing Java, or using the REST assured. You can create your dummy producer and a dummy consumer, and you can use REST assured or some API testing tool to listen to those events using that topics.
Thank you, Saurav. I think we are running short of time. You can answer the rest of the Q&A in the session offline, okay?
Okay, sure. Thank you.
Thanks a lot for your presentation. That was so insightful. Let's move on to the session. So before going to the next topic, can we have a quick poll, please, for the feedback, people? So this poll is specific only for this particular talk, event-driven architecture. So please give your feedback. Yeah, we are seeing 50% of them have answered. Others, it is not going to take much time, just a few seconds, few clicks. I'm seeing few of you are raising hands. If you have questions, you can post it in the Q&A. We are actively answering the questions in the Q&A session. And also, I think we are actively engaging you in the comment session. So please keep them coming. We cannot unmute anybody. Okay, few like I think you have to. Few of them are saying that they cannot see the poll. I think it might be minimized or something because it will be for all the attendees. Can you just check your all the windows it's maximized or not? Just couple more clicks, then we'll just get going. Yeah, while we are at the poll, do you guys need a break? What do you all think? 5 minutes break? Okay. I'll take 2 or 3 people saying yes as an yes. Yeah, we'll just break for 5 minutes. Yeah, I think we can end the poll now. Thanks to all of you who have actually shared the feedback. We're ending the poll. Now we'll take a 5 minutes break. While we are at the break, we are having a small quiz coming right away to you. We will not be talking, but just look at the question on the screen and keep your comments, answers coming if people who are not going for a break can do. Thank you all. We'll join back after 5 minutes.
Hello everyone, welcome back. Hope you had a nice break, and whoever playing quiz, I hope we kept you engaging for the last 5 minutes as well. I really hope the webinar is going good for all of you. Let's continue with the webinar now. We have our next talk already. So this one is from Samina Syed. She is a solution-focused quality engineer having around 6 years of experience in functional and non-functional testing of both web and mobile applications. Today, she is going to take us through a deep understanding of how to use Scala for data-driven testing. So as for all other talks, we'll also have some Q&A at the end. So please bring your questions into the Q&A section. Over to you, Samina. Samina, you're on mute.
I'm just sharing my screen. One sec. Yeah. Hi everyone. Welcome to vodQA, and I think you are enjoying the sessions. Now we're gonna talk about this session. We're gonna talk about testing ETL engine with Scala. So in the next 30 minutes, I'm gonna share my experience on testing ETL engine with Scala and what is ETL and how we gonna do the testing on ETL engine, more about QA perspective, and we're gonna learn about what is Apache Spark and Scala, and then we'll see a few of the testing techniques, how we can do the ETL engine testing, right? So let's get started. So if you are thinking about ETL engine, right, the main thing which involves in your ETL testing is around data. So welcome to the data world. If you are looking at the data, what are the few things comes in your mind? It's like what is the data and how the testing of data can be done, because it is a huge chunks of data what we are having for a different set of things for each application, right? So we'll be having a few things running in our mind saying what is data testing and what is data warehouse and what is ETL testing, right? So if you think about ETL testing and data warehouse and few other buzzwords, how they are differentiated from each other, right? So if you take a look at data testing mainly involves in your DB testing, where you'll be having the primary and foreign key, how it is mapped, and how your columns are null checks are done, and how your data types of your columns is defined in your DB. All such sort of testing comes under data testing. Then comes the data warehouse. What does it mean? Data warehouse is also belonging to the data testing, how it defines the data warehouse and how it goes with the data world, right? So data warehouse is a machine, like a station where you're gonna store your information from different sources, and then you'll apply your business intelligence on that and get your data from your data warehouse where you are storing it, right? That the process of getting the data from your data warehouse is called data warehousing, and where you're storing the data from different sources, the machine which you are storing, we can call it as a data warehouse. Then comes the ETL testing. We might be thinking like data testing is a part of ETL testing, and data warehouse also involved in it. Yeah, ETL testing involves the process of testing at different levels. So ETL stands for extraction, transformation, and load, right? So the testing of each stage of your ETL, like after extraction, after transformation, after the load, that kind of testing all together, we can call it as an ETL testing, right? So that's how we can differentiate between data testing, data warehouse, and the ETL testing. So let's understand more about what is ETL. So if you have any experience on ETL testing, you can put your thoughts in the chat, and what does it mean? Like what is ETL means to you? Okay. So let's look at this video. What comes to your mind once you see this video? What comes to your mind, right? Just you can have a chat like what means to you. This way, when you have a look at this video, what comes to your mind? You can relate the ETL process, what we are talking in technical terms, we can relate it with the real world, which is very interesting. If you see at this video, what comes to you in your mind? Like we can say in the physics, we'll call it as if gravity separation technique. He is taking the fruits and he is rolling on his own machine, whatever he's built on. And depending on the size, and it is going into the particular box that is the destination. So we can correlate with this, whatever we are seeing it right now in the real world with the technical terms, what is extraction, transformation, and then loading, right? Whatever he has the source, we can compare with the fruits. And whatever he is doing, the technique of segregating it, we can call it as a transformation. And wherever he is dropping the fruits, depends on the size, we can call it as a loading. So this is how we can map ETL with our real world scenario if you are seeing at this video. And then in the technical terms, what ETL does, right? So it is taking the data from different sources, say it is from a JSON file, or it is from a CSV, or it is from any DB, or any different kinds of sources, and we are applying the transformation logic on it, and then we are loading into the data warehouse. Or it can be any other destination, whatever you have. So you can store it in your file, or any destination, whatever is defined for your application, right? The total process, we are calling it as an ETL process. So taking the information from different sources, extracting, that means the extraction is done over here, and then applying the business logic on it, where you will be having different kinds of data flows, and you're applying your transformation logic on it, and then you're loading into your destination. So this is full process is called ETL process. Okay. Now we are clear on what ETL process does and what is ETL process. If you broadly look into the tools which we have in the market to do the ETL process, we can segregate into two types. One is GUI based ETLs and the other one is code based ETLs. So GUI based ETLs, mostly these GUI based ETLs will be mostly licensed and suitable for simple flows, because all GUI based will be having different kinds of flows where you'll be clicking on a drag and drop you're doing, and because of that it will be having different complex flows. We can't maintain it properly if you are having GUI based ETL. Even in our project, we had the GUI based ETL, which is nothing but MSSSIS, where we are calling it as a Microsoft SQL Server Integration Service. In that, the issues what we were facing, it was a legacy code which is written in SSIS packages. It was very difficult to understand what is happening with the which flow, because the source code, if you look at it, it will be very complex. And just say today I'm having the data source which is having 6 columns. Now tomorrow I want to add the 7th column, which is a requirement for us. So it was very difficult to go and put the one column in your ETL process. So it was so time consuming to edit anything into your ETL engine. So, and one more thing, we used to have the intermediate schemas, too many intermediate schemas. To derive your destined data, we should have the intermediate schemas, then only we can get the output of it. So it was very difficult and it was not testable. The main thing where we are facing the difficulty was it was not testable, because that was fully data warehousing knowledge is required for that. So that's how we faced few issues with the GUI base. Then we started exploring what are the other techniques we have to do the ETL. So then we started looking at Apache Spark, which we are differentiating as a code-based ETL, right? Here, Apache Spark is an open source, and the flexibility what we'll get is like other languages and whatever frameworks we'll be having. It is so flexible. You can, it is a testable, and you can write the test over it at different levels of your ETL engine process, and then easy to debug and maintain. These are the benefits whatever we are getting from the code-based ETL. So that's how we moved from GUI-based ETL to the code-based ETL, right? So let's look at more about what is Apache Spark and Scala. So if you look at the Apache Spark is a data processing framework which will do your data processing parallelly, and distributed data processing can be done by the Apache Spark. That's why we are calling Apache Spark as more scalable. And that's how we have chosen the tool of code-based ETL with Apache Spark. And then Scala. What is Scala? Scala is an other programming language where we'll be having the functional programming paradigm, right? So in this picture, you can look at the Spark components, whatever we have, and the capabilities of our Apache Spark. So we have the data sources like a CSV, text, Cassandra DB, and MongoDB, MySQL, SQL Server. All these are the data sources and destinations which the Spark gives you the capability of doing with. And then we have the Spark core, and this is the part where the Spark gives the capability of distributed data processing. And then you can see what are the language support we have. We have Scala, we have Java, Python, R. So that's why we have selected one of the code-based tool, which is Apache Spark and Scala, and we are seeing so much of benefits out of it. And these are the components of the Apache Spark. And let's see what is a Spark architecture. We are saying Apache Spark is more scalable, and it will do the data processing in distributed networks, and how it is possible, right? This is how the Apache Spark architecture looks like. We have one driver. We can consider all these things as each machine, each node as each machine, right? We have a driver installed in this, and we have the executors, and it will divide your data across your executors and get the report back to your driver. This is the capability of Apache Spark. That's why we are calling Apache Spark as more scalable, and it is faster, right? This is how it will do the data processing in distribution. Then let's learn more about ETL by looking at one of the example of ETL scenario. So the problem statement goes like this. There is an application which predicts the temperature of different geographical stations using past annual temperature data. So for this application, what it does, it just predicts the temperatures using the data from different regions of temperature and different stations data. For this application, we are taking a sample data sources, which is temperatures.csv file, which gives the annual reports of each station. And we have one more file, which is again one more data source for your application, which is stations.txt file, which gives the geographical location of each station. Then our transformation logic and the data load comes into picture, right? In transformation logic, we are saying we're gonna take a few columns from temperatures.csv and the stations, few columns from stations.csv, and we're gonna load as a structured data into your SQL DB. We are taking a destination as SQL Server. So that is the transformation logic and data load, what we are doing it right now. So let's look at the data sources, how it looks like. So if you take the stations file, what we are seeing right now, it is a stations ID, and we have each unique station ID, and we have the mapped latitude, geographical location of that station, and then we have the name of a station. This is one of the data source which is coming as a text format form. And the next data source, what we have is the temperatures.csv. If you look at this, we'll be having mapping between the SIDs of our stations ID and also from our temperatures.csv, right? So you look at this, I am using AM0037897, some station ID is there. And the map temperatures for that, I'm taking a sample data of 2017 year, right? So map temperatures of that stations we are looking right now, right? So my transformation logic goes like, take the SID and then latitude, longitude, and the name from my stations.txt, and calculate the average temperature from temperatures.csv and load it into my DB. So my DB looks like this, right? My data has been loaded with my ETL engine process, and if I go and query my DB, I'll get the details like SID, latitude, longitude, and the name, which is coming from our stations.txt file, and then T average calculated from temperatures.csv. So here, what is happening? Let's look at the structured data, which is output of my data transformation. Now data has been loaded, but if you look at keenly, what is happening? Duplicate data has been fed into the system, but that is not according to my acceptance criteria, right? So let's say to give you the real world scenario, how what happens if you have duplicate records in your application loaded. Sometimes your application might crash. Sometimes say this is my backend which I'm using as a DB, and then I have a service layer and my front end, right? My service layer doesn't know which record to pick up. Both are looking the same one, and if you are doing some query on it and you are getting two records, my service layer doesn't know what to fetch and pull it to your front end, right? In that scenarios, like let's say I have an e-commerce website and I'm gonna search for some Puma shoes. So I search for Puma shoes, which I wanted the model and everything I have selected, but I'm getting the two links. If I compare both the links, it is having the same data, right? When you see the overall impact on the customer satisfaction, if you are having the data load as a wrong wrong data has been loaded, the customer satisfaction goes wrong. Let's say one more scenario, like you're doing ticket reservation or something, right? If you are searching for some bus or flight or something, if you are getting same flights but having the same data, you'll get confused, right? Then the customer thinks, let's move on to the other system and see the reservation over there. So that's how it matters when you have the duplicate data, and if it is your scenario is not required the duplicate data, that's how it affects on the application. So now we have defined ETL process, which does the things for us, like taking the data and applying the transformation logic and loading into a DB. But now we have to consider the task has been done. It has taken the data from your source files and it has done the transformation logic, and then it has put into the load. But what went wrong, right? We saw just now what went wrong. Duplicate data has been fed. So if you are having the ETL process defining the ETL process, these things you have to consider when you're doing ETL process together. Transform data has been, is this the correct one or not? Say today I'm getting the data source as a comma separated. What happens if the data comes as a pipe separated? Today we don't have any data to do that kind of testing, how my ETL engine behaves when I get the pipeline separated data source, right? But our requirement says we can have the comma separated as well or pipe separated as well. So in that scenarios, we should be confident enough how our ETL engine behaves. And what about timelines? Right now we saw we don't have any testing around our ETL process, and we have loaded into our DB, and then we're gonna check in the query your DB and we're gonna check it. What happened? We are seeing the duplicate records. If you are doing your testing around end of your ETL, what about the timelines? How we gonna do it? So your ETL process is taking long time, and you have to do the testing of your ETL within the timeline specified. So these are the things we have to consider if you are defining your ETL process. Then comes to the challenges in ETL testing. These are the most commonly faced challenges in ETL testing. It is really hard to prove what data transformed correctly or not. Let's say my latitude is 39.173 or something. If transform data is giving me only 39, some data loss is happening over there, right? So all these kind of challenges will face in ETL testing. And then it's a huge data. Querying your DB and getting your validations done is a hectic task, right? You can't test your millions of records with your query, and you can't validate with your source and the destination data accurately, whether it is coming properly or not. And the time taken to complete your ETL pipelines will be high because we are dealing with a huge data. So how can we overcome these challenges, whatever we have in ETL testing? One thing which we can come around is having the tests around it. To think about testing at different levels of your ETL process. That's how we can gain the confidence on each task of my ETL engine does the proper job. That's how we can do the ETL testing, right? That's how we can put our mind saying we need some test over here, this is going wrong, or transformation is going wrong, or my load itself is going wrong. That's how we can think about a QA perspective in your ETL engine. Then how we can start writing our test either in an automated way, or once you derive your scenarios, how we can automate that if you have defined your ETL engine using Apache Spark and Scala, right? So we have one class which is a testing framework from the Scala itself, which is called the Scala test. So it is again a popular testing framework, like how the other languages gives us the support of testing frameworks. The similar way we have Scala test in your Scala. So what are the benefits we are getting by using the Scala test? We have the deep integration between most commonly used different tools like build tools like SBT, Maven, JUnit TestNG, and it supports the different styles of testing like XUnit style, which is called FunSuit, and flat spec style and BDD style. FunSuit, mostly it will give you the descriptive test names, and the flat spec you can go little deeper into the BDD style, not exactly like BDD style. In BDD style, you'll be having the feature files and the step definitions defined, like how actual Cucumber with any other language works. The similar way, the Scala test also gives us the capability to have these kind of styles. Then let's get started with how we can get started with writing a Scala test, right? So what are the steps involved to get started with your Scala test? The first thing which we are looking at is the descriptive test names. We can give the test names as the descriptive test name. Say I want to throw an exception when there is a duplicate data in my data source, and then you have to create your Spark context, which is nothing but your Spark session, and then create data frames. Data frames are nothing but distributed data with the named columns, like user defined column names. Let's say we have seen the stations file, right? We have a station ID and then latitude, longitude, and the station names. The similar way, I'll define my schema for my data type as well. So I can take whatever columns is required from my data source and it will be immutable. And then apply your logic on your data frames and then put your validations, whatever scenario you're testing with. So let's look at one of the data extraction code, what it does. So here we are seeing this is the dev code, and no need to go deeper into it. Just look at glance what it does. It is taking a Spark session. It created the Spark session, and it will take your source file, and then it will map to your data frame, which is your data frame. We are saying I want it to be a station ID and the latitude, longitude, and name. So your data frame looks like similar to your data source, which is having SID and the latitude, longitude, and the name, which is extracted from your data source. So I wanted to use this method to, how can I have the validation around duplication, duplicate record fed into my system? That kind of check I wanted to do. So we'll discuss the Scala test, how we can derive in the industry pattern, which says arrange, act, assert. This arrange AA pattern suggests us to do the test method to divide into arrange, then act, and then assert. Let's look at the similar way what we're gonna do it in the arrange section. So we have created one test class which says validate no duplicate stations entry, and then we are extending any fun suit. This is a XUnit style of Scala test. What does it mean? Fun means each test method, it is referring as a function in your test class. And then we have the before and after annotations, like how we'll be having in other frameworks, right? So you can create your Spark session inside your before method, and then you can do it in the, you can kill it in the after session, you can close it. The similar way, we are gonna use a one test class extending your framework, testing framework, XUnit, any fun suit. And then we have the descriptive test name, which suggests throw an exception if there is any duplicate entry for a station. And then we're gonna create our Spark session, and then we have our data frame. In data frame, we have the data, which is fed from your source file. And then we have given the names like SID, latitude, longitude, which is nothing but your station ID, latitude, longitude. So I'm gonna perform action on the derived data frame. What it does, we're gonna create one more data frame which says I want to select only the column of SID from my data frame, which is extracted from my data source, and then I'm gonna perform distinct action on it, which means you're saying, let's say your station file is having some 300 station IDs, okay, but station A is coming as 5 times. So the count, if you see for this data frame, it will be 296 only, because it is taking only the unique values for your station ID. If you look at the data frame 2, what it does, it will take all the columns of your SID. It won't distinguish between whether you have the duplicate entries or you don't have the duplicate entries. So on that we are getting the count. The count of first data frame will be having only 296, because we have the duplicate records and we are performing the distinct action on it. And the count 2 is having all 300 records. Now with this count match, we can figure it out whether your data is good data or we have the duplicates in your source data, right? So we're gonna assert saying just get me the count of it, either it is matching or not. This is how we can have the validation around your duplication checks on your data source, which is coming under. Then I am confident enough to say my data is not good data. Don't feed into my ETL engine. Don't perform any actions on extract, transform, and load. Just stop it, because we are having the duplicate entries. According to our acceptance criteria, we should not feed into our DB or destination with duplicate data. And the overall structure of your Scala test, if you look like, it looks like this. we have the test class and the test method inside that, and which extends your any fun suit. And then we are gonna we created the Spark session, and first data frame, which is your extraction of your data source, and the second data frame, which is having the unique station IDs, and then we have the second data frame, which is having all the entries for your station IDs. Then we are setting on your count. This is one kind of test which will give you thoughts on how we can do the data testing or data validation checks in your ETL process. And this is one more test which suggests you to do the data validation after transformation. Our transformation looks like we have to take few columns from stations file, and we have to take few columns from our temperatures file. On top of it, we have to merge the both and fed into our DB, right? But how we can make sure like whatever data is coming after transformation is matching exactly with my data source. The example, same example, like I'm getting 39.1234, and after transformation it is rounding off to 39, because your code will be getting checked in from different developers, and you don't know which flow will break your ETL engine process, right? So for that purpose, we can have one validation, this kind of validation, which will do the check on your transform data itself. So if you look at here, again, we have created the session, Spark session, and then we got the temperatures file fed into our system and the stations file, and then we have created the data frame for our temperatures file and the stations file, and then the transform data frame is a combination of your temperatures file and the stations file, and merge it together, we'll be having the transform data frame. So I want to perform a query based SQL query based things to get the column of our source and the column from our transform data. So for that purpose, we are doing a temp view on my stations data, which is my source, and which is the expected one for our test, and then a transform data, which is the actual, which is after performing your transformation logic, we are getting the actual one. So what I have done, I have taken the column from my stations data, which is latitude again, and taking the latitude from my transform data, which is the actual data, and then I'm comparing both are matching or not. If there is any data loss is happening in between your transformation logic, we can have it check around this. We are saying don't load into with DB because some transformation logic is not working according to our need. So this is how the test looks like in Scala. And then reporting, XUnit style of reporting, you can see over here, which says what is your test class name and what test method it has failed and paused, and how many test cases passed for your each scenario, right? So this is how it looks like, and you can have the extensive reports on it if you want to derive. If you are having the report generation for your ETL process, you can define your own extensive reports like HTML reports. You can have a TestNG and BDD also, it's possible. And then how your test helpful in your ETL pipelines. Usually we'll be running our ETLs in pipelines, and we are doing data load at odd timings and into our applications, right? So how your test suite, whatever you have written, will be helpful in your ETL pipelines. Just have a think on whatever tests we have seen right now. One is for the duplicate data validation, and one is for the transform data validation we have done, right? If you are integrating your test suite with your ETL pipeline, you can have checks around your data. First, you can run your data validation test. If this one is failing, don't run my extract transformation and the load data. This one will get you the early defects saying data is not the good data which we got in data lake. So we can stop our ETL pipeline and give it to the respective teams to have a check on that. And then if you have the transformation logic test, like integration test, what we have seen right now, the transformation logic test, and if you are having some issues with your transformation logic, say data loss is happening, or month is not having month is going beyond 31 days in your month, or it is more than 12 in your month. So in that case, what you have to stop your integration test, or you have to stop the load, which is time taking in your ETL pipeline. If your integration tests are failing, just don't load into my DB. Anyway, the transformation logic is breaking. So that's how your ETL test suites can help at different levels of your ETL process, right? This is how we can define our test suite, and where the QA perspective towards your ETL engine, we can help for the ETL pipelines. And then let's look at the different testing techniques. What we have seen more about your data validations and the transformation logic checks, right? We should have some validations between your loaded data and the source data. And if you're doing it manually, it is a huge data, and it is a time consuming. And then comes the count of, if you are running behind your timelines, you can go with your count on the how many records I have in my source, and I can check with the destination records, and a few checks on your threshold values, like how we discussed about the month cannot be more than 12 in a year, and how the month days should not more than 31. The same kind of threshold values for the particular data we should have. And then duplicate data, what we have seen right now, and the transformation rules, either if your data flow is working today, it might break tomorrow, because so many development is going on in your ETL engine. This is how we should have the transformation checks. And at the end, we should have the system behavior validation checks as well with the loaded data. Your system today, it might be working fine. Tomorrow, if your data is coming with something special characters which is not system behavior with my loaded data. So all these kind of checks, we can have the different techniques around your ETL process. We can define different levels of testing for our ETL process, right? So just a quick recap about what we have learned in the session is more about what is ETL and how we are doing different ways to do ETL, and the challenges what we are commonly faced in ETL testing. And then what is Apache Spark and Scala, and why Apache Spark and Scala, we learned about that. And then we had a few Scala tests and few examples on it. And then we had automated test, how it will helpful in your ETL pipelines, how we can think about integrating our test suites with your ETL pipelines, and what are the different testing techniques test in your ETL process, right? So this is a quick recap about what we learned now. And if you would like to have one sample ETL engine, whatever the scenario we have seen right now in your local mode, you can check out the code from the GitHub, which is provided. I will be sharing the slides with you. And sample data files, like if you want to play around with the used data files, you can get it from the FTP server, whatever is defined over there, which is used in our scenarios. That's all I have about ETL testing. Thank you so much. I think this is you got the glance of how we can put our brains as a QA in your ETL process.
Hey Samina, can you quickly look at the Q&A, and there is one or two questions, I think you can choose to answer them if you want.
Sure. Testing ETL engine, as everything revolves around data a lot, ETL testing has a big scope. What steps should one take to start on it? So first, understand how the data is coming into your system, and then have a overall picture what it does and how it is getting loaded into your applications. And then you think about what is the ETL engine we are doing right now. Either we are doing it manually, or either we have already defined GUI based ETLs, or code based ETLs, whatever is there, and just have a look at it, what each process, how we are managing at it, right? So then you can think about how to test it. If you see the flow, what it does your ETL engine, then only you can understand where and all we can apply our QA thoughts on testing your ETL process. Okay. And what are the things need to be taken care while doing ETL testing? I think we have covered this part, and where and all we can have tests around it. Uh,
Yeah, I think that's all we had, Samina.
yeah.
People, you can also reach out to Samina offline if you want. Thanks a lot, Samina, for that awesome presentation. I hope we all had some takeaways. Samina was so immersed into data that she didn't even notice her screen share, like her virtual background was actually tilted. That's okay. Yeah, just moving on. I know that you all know the drill now. After this talk, you're looking for feedback. Please vote. Your valuable feedbacks are very much useful to us. I can see at least half of them voted, but I think it will just take a couple of clicks, people. Just 3 questions. Please vote for the poll. Are you all with us? All the other 50 people, have you put on your audio and sleeping? Are you looking at the screen? We are seeing like lots of people are raising hands. I'm sorry that because it's a webinar and there are lots of people, we cannot unmute each one of you and let you ask questions. Please put your comments or questions in the Q&A and the comment session, please. Yeah, someone is asking to share the poll link. Poll results maybe we can share, but poll link we cannot share. At the end of the webinar, there will be a poll link coming to you. You can give your feedback there as well. Yeah, you can rate for the overall session, Chandan, no worries. Okay, I think we are 60% now. Let's move on to the next one. Can we end the poll? Cool. So moving on to the last but not the least talk of the webinar, which is testing on cloud native apps by Lipika Jaskaran Dugar. To tell a few words about Lipika started her career with ThoughtWorks and it has been more than 5 to 6 years now. Lipika is very passionate towards delivering quality products. She is skilled in both manual and automation testing, and Lipika likes to keep herself updated with the latest testing trends. So that's why she is here with us today to share with us her experience on testing on cloud native apps. Welcome to vodQA, Lipika. Yeah, over to you.
Thank you, Purnima, for the introduction. Hello, everyone, and a very good afternoon to all of you. Hope you really had a good insights on various topics. So now in next 30 minutes, if there is something that I would like you to take away from this talk is understand what cloud native is, how is it different from monolithic architecture, how can Kubernetes help in testing cloud native apps, and what software testing is all about in cloud native applications. So if you have any questions during the talk, please put it in Q&A section. I will try to answer these questions at the end of the talk. So yes, let's get started. Let me know if you can see the screen. All right. Hope everyone can see my screen.
Yes, Lipika, we are able to see and hear you properly.
So we have been hearing this term quite very often, right? The cloud native is becoming a very buzzword. So, but what exactly is this cloud native? So in cloud native app is an approach to building and running applications which uses the cloud computing delivery model. It helps in running scalable applications. It is also now considered to be the future of app development. And moreover, these are the figures from Google. So just bear with me. So 28% of our applications are likely to be migrated to cloud native by 2022. And now with cloud native architecture being actively adopted for software development, we QAs should also start working towards this. So without a much ado, let's first understand the difference between monolithic architecture and cloud native architecture. Well, when we talk about monolith, we can now say that this is the traditional model of app development, where all the components are tightly coupled to each other. For a small functionality change, we need to redeploy the entire application, which would take a lot of time for the deployment process, hence becoming a tedious job even for the QAs to perform regression on the entire application. And because deployment takes a lot of time, most likely deployment is done once in 6 months. While on the other hand, cloud native is pretty much the opposite to monolithic architecture. Every component, as we can see in the diagram, these are called microservices or containers in cloud native. So in cloud native can have a various architecture. Here we have taken an example of a microservice architecture. So we can see that every component in cloud native is loosely coupled to each other and is independent to each other. These containers are then connected via cloud. Since every component is independent to each other, as we can see, it becomes easier to maintain and becomes a shared responsibility to manage. In cloud native, for a small functionality change, we just need to make changes to the existing component, unlike what we had for the monolith architecture, right? And deploy the same. And even the QAs can focus on the respective component. So in cloud native, it is always believed to release early and very often. And some major advantages of a cloud native app is its ability to scale. And I think tech folks would also love this, that it allows the freedom to choose the tech stack. And now that we know the difference between monolith and the cloud native architecture, let's understand how is testing defined in each architecture. So testing in monolith architecture, like we all know, is something that we do after a feature or functionality is developed and before it gets deployed to the production. While in cloud native apps, since everything is hosted in cloud, we testers need to be alert all the time. And as Teresa pointed in her talk already, that testing should be a continuous process. We need to test every stage of software development lifecycle, be it a small bug fix or a functionality change. And after every build, developers can push the changes to the cloud and we can test them immediately. Not only in the dev environment, we need to ensure that testing is done during the deployment and even after the product is released. So essentially, we QAs are always testing. And so with cloud native apps, we know we will never run out of work and our job is secured. Or we can also say that development and testing in cloud native happens at a common place. And yes, this reminds me of a very famous analogy and a very common name that is rotating in the internet, right? So in fact, there is no cloud. It's just someone else's computer. After all, it's a common server that is used after all, right? So, but one more thing here is cloud native architecture was not developed in just one day or is not an overnight discovery. It has, like we can see in the timeline, it has evolved over the ages from virtual machines to containerized Dockers and then to cloud native Kubernetes. In fact, when we talk about cloud native, right, the major turning point in cloud native architecture was the introduction to Kubernetes. Kubernetes, or KATS, popularly known as, was initially created by Google and was later taken over by Cloud Native Computing Foundation, CNCF, as a fully open source project. So what is Kubernetes? Kubernetes is an open source content and a container orchestration platform, which is responsible for effectively managing the application deployments. And CNCF, like I already mentioned, now is responsible to manage the Kubernetes project. With this evolution, there's a lot of demand for expertise in Kubernetes. And eventually, Kubernetes will just affect everyone involved in the software development lifecycle. The developers, DevOps are already in the space. And just to mention, Kubernetes is also going to be a time changing even for the testers. So we often hear Kubernetes being compared with Docker. Let me tell you, it's actually not Docker. It's actually the Docker swarm that is referred here. So it always makes sense to compare the Kubernetes with Docker swarm. Docker swarm is actually the Docker's own native clustering tool. Kubernetes and Docker swarm are comprehensive de facto solutions for intelligently managing the containerized applications. Even though they offer similar capabilities, the two are not directly comparable as they have distinct roots and solve very different problems. Based on some of the comparisons that we see here, Docker Swarm is ideal for users who want to set up a containerized application with no complex configuration and want to get it up running without much delay. As we can see here, it deploys the containers much faster, right? And it does not support much of auto scaling and has very less experience in the production space as well. So anyone who would want to just spin up their application just quickly, the Docker Swarm is the best example. While on the other hand, Kubernetes would be the best containerized platform to use if the app we are developing is a complex and utilizes hundreds of thousands of containers in the process, as it supports high auto scaling and a lot of deployment at scale can be done in the Kubernetes. It has high availability policies and auto scaling capabilities. So in this talk, we will focus more towards the Kubernetes and understand its architecture and how it helps in the software testing. If you have any further questions around Docker Swarm or how it operates, we can always go back and have a look at it, right? But let's focus about Kubernetes and its benefits in the cloud native as it supports the complex applications. So before getting started to the Kubernetes architecture and understand what are the various features of the Kubernetes, let's check out some of the commonly used terms in the Kubernetes world. So here are some of the terms that you can hear very often when you are getting introduced to the Kubernetes, which are pod, kubelet, etcd, kubeproxy, cluster, node. So you can just walk through all these terms and it's okay that if you don't understand all the terms right now, we'll explain it in the later slides. So pod is a set of containers deployed to a single node. And I assume everyone understand what container is. For those who are new to this world, a container is a standard unit of software that packages up code and all its dependencies so that application runs quickly and reliably. And it is an independent component in a cloud native architecture. Similarly, kubelet is a container agent, which we will explain about etcd kubeproxy in the later slides. Cluster is a set of nodes and node is responsible to perform the task assigned by the controller. Similarly, we have the persistent volume. Persistent volume, it stores the data so that it can stay for a longer time frame. And service is a method to deploy the application in the network or in the internet. Similarly, the deployment ensures to automatically spin up the pod in case of any failures. So these are few of the terms that are widely used and you would hear them very often when working with Kubernetes. For your reference, I've tried to add as a one-liner explanation, which we can always go back and refer. So now coming to the Kubernetes architecture. So there are majorly three components in Kubernetes architecture: master node, worker node, etcd, also known as key value store, or a metadata service. So what is a master node? Master node is the first entry point where all the tasks begin. As you can see in the diagram, we have a master node and a various worker nodes, right? Which are Kubernetes nodes that we often call it as. So master node is a place where all the tasks begin. And the controller manager and the scheduler is responsible for controlling and managing the worker nodes. It is responsible to assign the tasks to each the worker node. On the other hand, worker node is any physical or a virtual machine which runs the application via pods and is controlled by the master node. So here, although it is any machine, it has its own machine, it is controlled by someone else, which is a master. And again, worker node has three components: pod, kubelet, and kubeproxy. I think we have already seen what pod is in the previous slide, which is a scheduling unit. And every worker node will have one kubelet and a one kubeproxy inside it. So as mentioned, kubelet is responsible for communicating with the master node. It is actually an agent between the master node and the worker node, while the kubeproxy takes in requests from the users and then acts as a load balancer to select a pod based on the specific set of rules. So now that we have understood the architecture of Kubernetes, the high level, here are a few features of the Kubernetes, as in why do we need to, what support does it offer us, right? So Kubernetes is a well-known because of its feature, which helps in seamless deployments of application. It supports easy auto-scaling of clusters and automated rollouts of features. If something goes wrong, we can immediately roll back the cluster even in the production. For example, we can automate Kubernetes to create new containers for our deployments, removing the existing containers and adopt all their resources to the new container. And it ensures that the container is up and running. Only then it exposes the container to the client's interface. It also offers significantly high availability as it distributes all the pods among the nodes. So if one pod goes down, it immediately spins up the another one so that there is always a high availability of the pods. Kubernetes has a flat network model which allows all the pods to communicate with each other. Also, unhealthy pods are detected by load balancing services, which subsequently gets deactivated and another pod gets up and running. Self-healing feature of Kubernetes ensures high resiliency of an application. If any container fails, it immediately replaces the container and it is available to the users. So these are some of the features of Kubernetes which makes it so popular. And well, if we think that Kubernetes is just a container or an orchestration tool, then it is more than this. It is actually like a Swiss Army knife, which provides various services and makes life simpler by automating a lot of processes. So now let's take a sneak peek on how can we leverage these Kubernetes features in testing cloud native applications. So Kubernetes has changed the way we think about running containers at scale. So far, developers and operation teams have enjoyed working with it, as it enables agile and resilient delivery of the applications in the cloud, right? But what has changed is the execution model of the different types of testing for cloud native apps. As each type of testing in cloud native, be it unit, integration, or system, it requires different setups and configuration. So it takes time and effort to automate these stages. However, with Kubernetes, we can have a platform that scales based on our requirement. We can also leverage this to incorporate more advanced testing scenarios such as chaos engineering or A/B testing on real production sites, so as to reduce the risk and make our systems more resilient to failures. What we can also do is, in case of a stress testing, if you want to do it right, we can spin up the machine as per our requirement based on the testing setups and the data, and use that environment and then dispose it as soon as the work is done. So this ensures that we have a cheap disposable environment and we need not even worry about the cost. Kubernetes has also made the debugging process much easier with availability of logs to every member in the team. Every member of the team can easily log into the test environment hosted in cloud and access the logs. Like for example, we testers often find bugs, right? And when we report to the developers, they would ask for the logs. So what they can do is they can just log into the test environment and check out the logs. So this ensures that there's a fast feedback and smooth communication with the team. So unlike monolith architecture, we are now moving towards the shift left testing model as our testing begins right from the unit testing phase itself, ensuring we test right from the beginning. And now, given that the industry is moving towards the cloud native architecture and shift left testing model, it now becomes crucial for every QAs to produce better test plan strategy. So there are various measures in cloud native architecture like scalability, resiliency, robust deployments, and resource utilization, which not only ensures the better deployment of the application, but also ensures efficient and effective testing. So scalability is nothing but is ability to scale the containers or pods based on the real-time requirements. Say for example, during big billion days or any sale on Flipkart, there's a sudden spike of the number of users, right? Even yesterday and day before we had this sale going on Amazon. So what we need to ensure during this time is the containers are automatically scaled up to incur such heavy demands based on data storage capacity or the processing power. One cannot afford having a less performant system in the production, right? So ensuring that the containers automatically get scaled up when in need and auto scales down when the usage is less. So this also helps in the cost cutting for the applications. So, and as QAs, some of the basic scenarios to cover here would be what happens if the instances are not longer used, right? So just scale it down. How is the service scaled? How is traffic routed when nodes are overloaded? In such auto scaling testing, we need to watch out for any memory leak if all the threads are being closed, along with the proper logging and CPU utilization. Coming to the another measure we have is resiliency. It is the ability of how can we recover the failed cluster without losing the state. Like say, for example, we are in the middle of a payment gateway and suddenly the app crashes. So in this scenario, we need to ensure that proper load balancing happens and redirects to the disaster recovery cluster, because no application or no business can afford having the system down even for a couple of minutes, right? It would incur a huge amount of losses. So, and also apart from the redirecting to the disaster recovery cluster, we also need to ensure that there is no impact on users' experience in terms of functionality or the performance. So this also helps in maintaining the impact of the cost associated with the business. So here, some of the things that we need to handle is, does the system degrade gracefully? Can we still respond to user requests if the legacy systems are unavailable? So when we come to the Kubernetes and cloud native, Kubernetes can perform rolling restarts and ensures the automated spin up of disaster recovery clusters in such scenarios. So next, coming to the robust deployments. So when one of the important key factor in the deployment is the automation, right? Automated deployments and the automation tests that runs during the deployment. So when planning out the automation efforts for cloud native apps, we should focus on the valuable areas and not focus on automating everything. Like in the beginning of the vodka session, there were many things that had come, right? Like 100% automation or something like that. So here we focus on automating only the valuable areas. Since time is limited, I would not say that not automate, but we can keep it for the regression areas. But during the deployment, let's ensure that we focus on the major parts of the deployment. Since time is limited, it won't be possible or add value to automate everything. Hence, focusing on the valuable features and ensuring the test packs are robust is a key point here. The focus should not be on large, unmaintainable, unreliable regression packs that add no value, but smart packs that can simultaneously validate a deployment and perform a selected set of functional tests. So this type of automated regression will add constant value to the deployment effort and the development, and accordingly can be expanded or reduced as the product matures. So if there is a huge product that is already there in the market, then there are certain scenarios that is essential to get automated, right? So as the product matures, we can always think of having it more or less depending on the need. So next, coming to the resource utilization. So in the traditional applications, operations team would manage the infrastructure resource allocations manually. While in cloud native applications, resources are utilized via a central orchestrating process that dynamically manages and schedules the containers. And since this is based on certain rules set by DevOps, we need to ensure the right balanced loads are maintained. Otherwise, it can result in low resource utilization or increase the response time for the tests. So this also reduces the cost associated with maintenance and the operations. So with while much of the functional aspects don't change too often in the cloud native application development, the cloud actually offers and sometimes requires very different ways to meet the non-functional requirements. Because when we develop the application, this is majorly focused towards the infrastructure level changes. So cloud native alongside offers a lot for testing in itself, and at the same time helps testing apps in a better way. So let's look at how cloud native helps in achieving end-to-end automation, A/B testing, performance, and the security testing. So A/B testing is nothing but releasing a version of the product to specific set of the users. So when we perform an A/B testing, what we do is we route a subset of the users to new functionality based on the routing rules, as we can see in the diagram as well. So some one version is deployed to a certain set and the second version is deployed to the another set. And based on the result that we get captured, we take a decision on what can be rolled out to the production for all the users. So routing rules, and also one factor that that comes for the routing rules is browser version, user agent, geolocation, and operating system. So there are certain factors that are responsible to come up with these routing rules. And after we have measured and compared the versions, we update the production environment with a version that has the better results. A/B testing ensures while there is a zero downtime, we can test a feature with real-time production users and also monitor the traffic. So VQAs also need to play a role here, especially while selecting the target audience, and run the test for a reasonable period to reach the statistical significance of at least 95%. Otherwise, it would not have much of impact on the results. A few things that needs to be considered here while doing the A/B testing, and a few challenges that comes here are several factors can actually skew up the test results, including the false positives, biased samplings, or external factors such as maybe marketing promotions or the seasonality, right? So observability, which we will talk about it in the later slides, it can potentially be a challenge when we perform such testing. So when we run multiple A/B tests on overlapping traffic, the process of monitoring and troubleshoot can be difficult. To put it in a simpler terms, let's take an example. Say we test a product page A versus product page B. It can be a search, right? Or checkout page C versus a checkout page D. So in this scenario, distributed tracing becomes an important measure to determine these metrics. So next is the performance testing. So performance testing in cloud native apps is a challenge here because everything is hosted in clouds, and we are all talking about scaling up the application to a huge amount, right? Huge storage, huge processing power. So performance testing becomes a lot of challenge and is very important as well. There is actually a fundamental shift of approach while we do a performance test in the cloud native application. For monolith applications, we have always been hitting the URLs to do the performance testing. But for cloud native apps which are hosted in cloud with various containers, instead of hitting the URLs, we would also now look at the cluster and the container performance. So we are now moving towards from the URL approach to the container based performance. I would not say that we do not hit the URLs, but something that we need to consider in cloud native application is the performance of the containers as well, which is the core of this architecture, right? So we need to see that how much time does the container take for the request or the response time, rather than just looking at the end point, because eventually when the users request for any functionality or hits an API, it would redirect to one of the nodes based on the load balancing rules. And moreover, with load balancer in between, while doing the performance test, we need to ensure the right balancing of request is sent to various nodes based on the configuration or the rules that have been set for the load balancer. Also, we need to have a very good system monitoring tools. Although everything is automated here, we still need to observe the logs and keep track of the container logs to ensure the troubleshooting and the tracing of the feature. One of the major challenges that we see here, and as something that as QAs we should keep in mind while coming up with the test strategy, is the test data preparations, or what data or what size of the data is being used for performing the performance testing. As in, what kind of data are we sending it to the nodes or the containers? Because the containers and the nodes are all configured, right? It can have a different requirements. Every node can be set up with a different configuration. So that we need to ensure that what kind of data is sent to a what kind of node with what configuration, and then analyzing the results accordingly based on both external and internal to the clusters. So next is the security testing. So security testing is again a key here because everything is in cloud and most of the endpoints are exposed here. So something that we need to consider here is definitely the security testing, which is very much essential as it is all revolving around the data, right? So nowadays, all or most of our applications are hosted in the cloud, and since everything is hosted in cloud, it obviously becomes a challenge for cloud native application. And it is very crucial to have security testing because it might have some sensitive information or the sensitive data which is present, right? So the main objective of cloud-based security testing is to stop any threat or malware from accessing, stealing, or manipulating any of our private data. It identifies the threats in the system and measures its potential vulnerabilities. One advantage with cloud-based application security testing is that it can be applied to a larger application with low to medium risk, and even to application with a strict budget or time restrictions. Cloud-based application security testing gives the feasibility to host the security testing tools on the cloud for testing. So when I say that even for the application which has a limited budget or the time restriction, what we can do is we can just host these security testing tools directly in the cloud and then test the features. So with this process, tools on the cloud can test the applications. But earlier in traditional testing, what we had to do is we need to have on-premise tools and infrastructure. And now the industries are adopting cloud-based testing techniques, which makes the process faster and the cost-effective. So the next, coming to the end-to-end test automation. So when we talk about the end-to-end test automation in cloud native apps, the best example to talk here would be the Selenium grid, which is mostly used even today to achieve the end-to-end testing, right? So we have been using, we have used automating browsers to run our test, right? So in this, what we can do is, earlier what we have been doing is we have been automating these browsers in containers that can either be deployed in the standalone or via the Docker swarms. And in Selenium grid, we must have definitely come across a very common error while automating this test, which is error communicating the remote browser, or it may have died, or unreachable browser exception. I hope if you have used the Selenium grid, you must have definitely encountered this error, right? Yes. So in such case, what we can do is we can deploy the browsers in Kubernetes, which brings in all the advantages like self-healing, which is when a node or pod goes down, it can automatically spin up, like what we have talked earlier, right? And from a scalability perspective, with just one command called replicas, we can scale the number of browsers we need, which may not be the same in other technologies. And with Selenium 4, which is now trending a lot, we can also enable tracing capability to monitor the system. So when we talk about the tracing capabilities, tracing is one of the most important pillars for measuring the observability of an application along with logs and metrics. So what is this observability? We have talked about observability, right? So what is this observability? So as defined in the Wikipedia definition, it is a measure to determine the internal state of a system at any point in time using only the outputs or the external factors. So here is a simple sample project, the link for which is given here. You can always go back and refer to here. So this is to showcase how tracing capability in Selenium 4 can be integrated with Selenium Grid. We can see the tracing logs for the requests here and how it can be traced back. So for more information on this, you can always reach out to Manoj, who is one of our panelists. So Manoj is already as a panelist here. So in case if you have any questions, you can just go through, try this sample project, and then you can go forward. All right, I think we are just in time, and we are also towards the end. And now with applications being upgraded towards cloud native apps, we QAs also need to upgrade ourselves. Testing has always helped us build applications that are more maintainable, debuggable, reliable, and performant, right? Which allows us to ship faster and with more confidence. But as applications have overcome and this has become more and more complex, new types of failure methods or new types of failure modes have been introduced, which are becoming more difficult to anticipate or troubleshoot. And especially with industry being moving towards the cloud native apps, which brings in a lot of features in itself, right? So in order to efficiently detect, debug, and fix them, we as QAs it's time that we should also review how we can use our traditional testing techniques to embrace these new ones and apply them to all stages of the development life cycle. Because in this architecture, we need to ensure that we are testing at every phase, like we have already seen, right? We do it perform during the development, during the deployments, and even while it is already in the production. So at every instance of time, we have always been testing. And only then, once we ensure that we have made use of our techniques and then looking forward to new ways on how we can do it, and only then testing can be the valuable ally as it once was in delivering the high quality software. And with this, yes, I would like to conclude saying, let's take over the cloud before cloud takes it in its own way. Thank you all. You can also connect with me offline via mail and check out my blogs on Medium. Yes, thank you. And now I think, let me check out the question answers. I'm now open. So let me stop sharing. All right. Okay, quite a good number of questions. Can Kubernetes be installed into any of the local Linux host or on a VM? Yes, so Kubernetes, we can install it, and when we have Kubernetes installed, we can have some of the YAML files which is there and can host it on the VM as well. So Kubernetes is actually a container orchestration tool, right? And it works the similar way that Docker Swarm is used. But it's just that it offers in itself a lot more capabilities and features when talking about Kubernetes. So yes, so yeah. How do we do automation in on-premise and the off-premise? Testing in on-premise is something that we do it in the traditional approach, that we need our tools handy in and infrastructure also available. When we talk about the off-premise, I don't think I understand this off-premise, but yeah, for the on-premise, we need for the traditional ones, we need the tools handy in and infrastructure as well. And for the others, what we can do is we can have our tools already present in the cloud. So anyone in the member of the team can make use of those tools and then run it as part of the deployment itself. So what we can have is we can have a stage where we run our builds and have the automated test already running as part of the deployment. Okay, the next one is, I have seen Dockerizing the test cases, but how Kubernetes is helpful in terms of automation. If I have more test cases so that I can run in multiple pods to speed up my automation, is that a use case with respect to test automation? Yes, that is one of the use case that we have for the Kubernetes, that since it allows the pods to automatically spin up, like what I have given an example, right? So if any of the browser is not reachable, then what can be done is automatically another container or another browser that is hosted in the container can immediately spin up, and we will not land in we can land, it is not that we cannot land, but most of the times we will ensure that it is giving the right set of automations. Yeah, I think we have 5 to 10 minutes more. Okay. I see that resilience keyword mentioned by Saurabh and you. How is this important when compared to other aspects of testing? A very quick question though. So resiliency, right? So like even the Saurabh mentioned, resiliency is very important, especially when we talk about today's current world and how the industry is moving towards, right? So one cannot afford having a failure state remain, right? So the first thing the production and even the clients that, and it's from a personal experience as well, the first thing the clients would ask is, if there is a failure, how can we recover from that particular failure state? One very good example which Saurabh said was in the event-driven architecture was if the message fails to reach the or get to process in the queues, then we can have a multiple topics. So similarly here, when we have such deployments, and if the example was given, right? If the payment method is broken, or say for example, if in the Flipkart also, if we see the site off for some time, then obviously the users would try to go to the another system, right? They would not have that trust and they cannot afford that. So we need a backup system that can automatically spin up and automatically respond to such failure scenarios. So in this terms, yes, the Kubernetes deployment can be a very helpful because it has that feature of self-healing power, right? So what it does is whenever the container is down, it ensures, and especially when we have a load balancing. So when I mentioned about the load balancing, what it does is it is a constant monitoring which sees that if any of the pods are going down, and similarly which happens with the controller manager. So controller manager in the master node, it also ensures that, so what load balancing does it ensures that it gives the or it assigns the task only to the healthy pods, and the controller manager in the master, what it does is whenever it finds any unhealthy containers or unhealthy pods that are present in the worker nodes or in the application, what it does it shifts all the resources of that particular container, and then create a new container with similar access tokens, similar infrastructure, or similar configurations. One thing when I talked about the in my slide was a persistent volume, right? Containers can obviously spin up and we don't store much of the data there. So all the data is actually stored in the container persistent volume. And all the containers are connected to these persistent volume for the data. So whenever there is a pod that goes down or fails, the data is still retained in the persistent volume. So this is something that we need to keep an eye on when we talk about the resiliency.
Shall we call it a day, Lipika? I think,
yes. Maybe other questions I can answer them offline, and or if you have any further questions, please do reach out to me. The mail given and shared as well. So thank you all for having me here.
Yeah. Thank you so much, Lipika. I think you just opened our minds into the world of Kubernetes and testing cloud native apps. So I think she's answered as many questions we could like. The rest of the questions will be answered offline. And as repetitive as it may sound, it's time for feedbacks again. So we'd like to collect your feedback on Lipika's session. We at ThoughtWorks, we value feedback very highly, and we see it as an option, an opportunity for us to introspect ourselves and improve from it. So feedback is very important. You will see the poll coming onto your screens now. For people who might have joined via the browsers, probably there is a pop-up blocker or some other issue because of which you might not be able to see the polls. But people who have joined through the Zoom app, you will see the polls. So please do give us your feedback. We'll just take a couple of moments for that. While we are waiting for people to give their feedbacks, let me also take this time to, this opportunity to thank all of you who have joined this webinar, right from everybody at ThoughtWorks who worked as volunteers to make this event a big success, and all the speakers who put in a lot of effort in preparing their content and delivering it right tonight, today. And to you all the audience who've been lovely all through the 3 hours that we had. So I think we've almost got the feedbacks for Lipika's talk now. We will end the poll and go on. Yeah, thank you. Now once the webinar ends, you will get a link that will take you to a Google Forms page wherein you can give your thoughts and insights on how was today's the first time when we went remote. Anything that you wanted to change, anything that you want to see the next time, please do let us know in that. Also, all of the 4 talks that we had today that were presented, their slides and decks, everything will be put on to our vodQA website. So please go ahead and have a look at it. That should be helpful for you and serve as some reference. It's been a wonderful pleasure having all of you today. And I really hope that we can see all of you in the coming editions of vodQA across all India locations. Can I request all the speakers to switch on their videos, come say a goodbye to all of our audience now? Yes. So we have Punima, Litika, Saurabh, and Samina. I think Teresa has left as of now. I think a big thanks from all of us to all of you. Thanks for joining in today. I hope we were able to give you a lot of takeaways from today's session. Bye, everyone.
Bye-bye.
Thank you so much, all of you. Bye-bye. See you in the next vodka.
Thank you.
We have our volunteers as well. Aditi is there. Samar is there. Time to take a screenshot for our reference. Samira, could you also come in?
People, audience,
Yes, we have everyone. I think even the volunteers can switch on their cameras. We can just take a quick screenshot, I guess.
We have everyone now?
Yes. Yeah. Cool.
We will be posting the recordings and the slides shortly in the vodka website and the YouTube channel. We will put the link of the YouTube channel in the site for people who are asking for recordings. Thank you.
Great event, everyone. Thank you. See you all again.
Bye-bye.
Bye.
Thank you.